Okay, so thank you for coming today. So today I'm going to talk about geothermal opportunities, in particular for the NHS, and some work that we've been doing at the British Geological Survey. So just to explain to you what the British Geological Survey is, it's a public sector organisation in the UK. It's a research organisation, and we're impartial and we provide geoscientific advice to government, to councils and to anybody that comes and asks for it. We store a lot of data, geological subsurface data for the nation, and we work both in the UK and overseas. And in particular today I want to talk about how this work has been directed towards geothermal energy, that's using heat from beneath the earth. So just to start with a quick definition of geothermal energy, on this nice diagram you can see at the bottom the kind of pinky colour. So deep in the earth, the radiogenic decay of natural minerals causes heat, a heat flow, which means that as you go deeper in the earth it gets hotter, and there's also a small component from solar energy as well. And what that means is if you go down a kilometre in the UK, then it on average would increase by about 26 degrees. And so there is a great potential for low carbon heating, and if you go deep enough, power technologies that you can use. But you use different technologies to exploit this resource beneath our feet. So in this slide I'm going to explain how you can use the heat beneath your feet in different ways using different technologies. So on the left hand side is an image of a thermometer looking at the different types of temperatures that you can get from the underground, and on the right is a model of the subsurface looking at different types of geothermal technologies. So if we start off shallow underground, so in this first, the blue box, so if we drill just to a few hundred metres beneath the ground, either just into kind of solid rock or into old mine workings that have been flooded with warm water, then often we can extract heat from these temperatures of around, say, 20 degrees. And to use these in our buildings we need to use a ground source heat pump to boost the temperatures, but that's a very widespread resource in the UK. Then as we go slightly deeper, so down to maybe between 1 and 3 kilometres in the kind of gold coloured box on the diagram, then we start to see temperatures maybe between 60 to 80 degrees, and that amount of heat can be used in buildings for heating and hot water directly, so you don't need to have a ground source heat pump at those kind of temperatures. And those geologically are in areas that we would call sedimentary basins often, or sometimes hydrothermal is the word that's used for those kinds of geothermal systems. And then the deepest opportunity for geothermal in the UK is looking maybe between 3 to 5 kilometres, where we have deeply buried rocks, where we can use those for both heat and power, maybe with temperatures up to maybe 150, 160 degrees for example, and that's an area that is particularly geographically located, and I'll show some maps of those in a little moment. So there's a great opportunity there from anything just beneath your feet to kilometres depth for different temperatures to be used for a source of clean heat, decarbonised heating. So I just want to give a brief slide which is about some examples that exist in the UK. Now this slide just summarises the kind of scale of some of the projects that use heat from beneath the ground in the UK at the moment. These numbers are continually changing and vary a bit depending on how you classify projects. But if we start on the left hand side, you can see that on the ground source heat pump side there are tens of thousands of people with installed ground source heat pump systems, and these vary from individual homes and buildings. The picture shown is an example of a nursery school. But increasingly these systems maybe go a bit deeper and join into district heating networks and integrate thermal storage as well, so they're heating and cooling systems. So there's a lot of those in the UK, and there are a lot more being installed. If we move along the diagram, along the slide, mine water heat is something that the UK has a particular specialism in because of its old mining history, both in coal mines and metal mines. And there are around 5 operational schemes in the UK using mine water heat, which are up to about 6 megawatts in size. And there are a number more in advanced feasibility. Then when we come to the deeper geothermal schemes, depending on how you classify them and how you look at them, but there are 2 key deep schemes that Gus was talking about. One of them, Eden Geothermal, earlier on, the really deep schemes going to around 5 kilometres, and one at United Downs also in Cornwall. And an operational scheme in Southampton for deep hydrothermal as an example on this slide, which has been in operation for tens of years. There's also people looking at repurposing old oil and gas wells for heat in parts of the country. So there's a whole range of technologies here, so lots of different opportunities depending on the location of your particular site and the geology beneath your feet. So I'll now go on to talk about the opportunity, in particular looking at direct use heat, so in those sedimentary basins that are maybe between 1 to 3 kilometres deep. And there's a map on this slide which shows different colours, so I'll explain what those are, and you can possibly also see the small sort of red blobs, and that's the location of hospital sites, obviously of interest at the event today. So in this mapping of the location of hospital sites with deep geothermal direct use heat prospects, what we've got are some existing studies which are geological studies from beneath the ground, which are represented by the colours, and those are different, either aquifers, those are rocks that transmit water that are deep beneath our feet, so those are the yellow, the blue and the green colours spread across England. And there's also on this map the kind of pinky colours are the granites. So those are areas where there's a higher heat flow, where there's a greater potential for using the deep, what we call the fractured basement, the granites and so on, that are at deep, sort of 5 to 7 kilometres beneath our feet. So you can see from this there's quite a coincidence of major hospital sites with some of these units that have been looked at for their geothermal potential. I should say at this point there are possibly other areas in the UK that we could add to this map, but we're still doing that kind of work. So I'm just going to run very quickly through a few maps which are a bit more zoomed in of the map we've just seen, just to illustrate where hospitals sit in relation to some of these geothermal potentials. We've got myself and my colleague Andres sitting here, and we've got these maps on our laptops if people are interested afterwards to really zoom in and look at your particular hospital. So this example here is an example from the northeast of England. You can see Newcastle upon Tyne. You can see the hospitals in the red markers, and the contours and the colours on the map represent aspects of the subsurface geology beneath our feet. And the kind of warmer colours are the areas with potentially the greatest geothermal potential in this area. So you can see there are some areas, for example, to the south of Newcastle, where the geological structure means that there's more potential for geothermal heat in the ground. So I'll run through a series of these maps, just looking at different places across England. And I should say these are very preliminary studies looking at a big region across different parts of England. If you were going to move to actually look at a particular site, you would do a lot of more detailed work around that site. Okay, so the next couple of maps are looking at different geological formations beneath our feet. So on the left-hand side is a unit called the Carboniferous Limestone, which is very deeply buried across parts of northern England. And you can see that across that swathe of northern England, there are particular areas where we believe there's quite a lot of heat, what we call heat in place beneath the ground, which are the kind of warmer colours. You can see opportunities, for example, around Liverpool, North Manchester, and so on. And the diagram on the right is looking at a different aquifer horizon, a slightly younger geologically horizon, and again there is some overlap between some large hospitals, for example in the Cheshire Basin, which is this image here, where there's a geological basin mapped out, and similarly on the northeast coast of England. Similarly, in other parts of the UK, these are two more maps. So an example of a map from the south of England, in an area we call the Wessex Basin, where there's a number of hospitals that sit on that basin, which is quite a well-defined potential target. And similarly, running up the centre of England, a geological basin in an aquifer horizon. And then finally, a map from the south of England that's a bit more zoomed out, but again looking at this deeper carboniferous target, and again some examples of potentially prospective areas in the kind of Bristol and Bath area. So just kind of summarising that then on a map which has just the one colour for areas of geothermal potential. There were some hospitals that were had particularly high heat demand and sat over particular areas where it looked like there was good geothermal potential, and calculations have been made to look at the 30 top hospitals and look at the amount of CO2 that could be saved by using the heat from under our feet, and so that came to a large number, for example 281 kilotons of CO2 equivalent, which is 12% of NHS England's carbon emissions. So there is a huge potential source there with work still to be done, looking at the geothermal opportunity in the UK, the deep geothermal opportunity. And this slide is just to say, well, how do you move on from that? These are very regional studies, and they're kind of giving the maximum potential, and so the next steps are you move on to more detailed studies of your individual site to move from a kind of technical, theoretical potential beneath the ground of heat in place to how much heat you can get out using different types of technologies. I'm also just going to mention in this talk briefly about more shallow geothermal technologies or ground source heat, because if your hospital doesn't sit on one of these particular sedimentary basins or on granites in Cornwall, that doesn't mean you can't use the subsurface for heating and cooling and thermal storage. You can if you use different technology using a ground source heat pump. So these three maps just give an indication of how that is more applicable over the whole geography of the UK. So the map on the left-hand side is an example of the temperatures that you get at 100 metres beneath the ground surface. So you can see that there are some areas of the UK, those that are in the red colours, that are slightly more optimised for some of these technologies in terms of temperature, because they're slightly warmer. But there's a number of other factors that you take into account as well when you're designing these systems, not just the temperature. The middle slide shows the extent of coal mine workings across the UK, and again this is a big possibility for some locations that are underlain by flooded coal mines, where you can use the warm water in those coal mines, big volumes that you can pump out, pass through a heat exchanger and heat pump system to get big steady loads of heat in those areas. And then finally on the right hand side is a map of installed heat pumps, ground source heat pumps, from the MCS classification, and so this is the colours are per 12 kilometre square. So the red and the orange colours are where there's the most ground source heat pumps installed, up to 51 to 100 is the kind of orangey coloured, or 200 to 500 ground source heat pump schemes. So you can see that coverage is quite patchy across the UK where heat pumps are installed, but that they do cover that spatial area of the UK. just to explain a little bit more about the shallow technologies, so these might typically go down to about 100 or 200 or 300 metres depending on your heat demand and so on. And there are two main technologies. On the left hand side are open loop technologies where you drill a doublet of boreholes, and then you actually take warm water out, pass it through a heat exchanger and heat pump and put it back in. Another system is called closed loop technologies, where you have a system of pipework beneath the ground that exchanges the heat with the ground. And BGS is currently working with NHS England and the Energy Systems Catapult on doing a screening tool for those closed loop systems to help people, again in the start of the process of, is my hospital or my area suitable for a ground loop system, and what kind of things do I need to take into account. So with that, I thought I would just say, well, what do you do now? So you're kind of interested in geothermal potentially, you think that sounds good. So there's kind of then a workflow that you would go through that's very well known from different industries if you want to develop a geothermal project. And the diagram here is from a report on geothermal in the UK that I've put a link to at the end of this presentation. But essentially there are different stages where you look at the feasibility of your project. That includes both the technical aspects and the economic aspects, and also the public engagement aspects. And then you go through a detailed design and permitting type step. Then you drill some of your deep boreholes, test them and set up your plant, as it were. And then obviously you operate your system, and operational lifetimes are tens of years for these kinds of systems. In terms of what the Geological Survey can offer, we can offer information about the geology beneath your feet. So, for example, those kind of maps that I showed you, examples of if I wanted to do a scheme here, what would the geology look like in that particular location? What are some of the properties of those aquifers and those rocks? And they will tell you how much heat or thermal storage capacity you might have, and some of the risks and impacts of the drilling of the borehole. So with that, I shall stop with a couple of information sources if you want to know more. But really, I would encourage you to come and talk to myself after this presentation, and my colleague Andres is sitting here if you're interested in more site-specific projects, and we've got various maps with us that we can talk to you. So with that, I will stop and ask if anybody has any questions. Thank you. So that was just a question about kind of payback times for deep geothermal and so on. And it's not something that the Geological Survey has a great deal of interaction with on the commercial side of things. But Gus presented a talk about Eden Geothermal just before me and had some good insight there on the kind of costs and so on. So yeah, Gus, would you mind?
Yeah, so if you're talking about the costs of geothermal or ground source heat pump projects, it basically depends partly on the cost of electricity at the time. So if you imagine if you're got a COP of around 3 for an air source heat pump, you're paying however many pence you like for three units of heat. A ground source heat pump tends to be a bit more efficient than that, up to about 4.2, 4.5 maybe. But if you're looking at a COP of an inlet temperature of say 25 to 30 degrees C or even 60 degrees C, then your COPs are very, very, very much higher. So there's a kind of sweet spot If electricity is expensive, it's probably still makes sense to drill. If electricity is cheap, then probably other technologies would work as well. And of course the grid will decarbonise, but the to have the direct heat into the project will mean that you decarbonise that much quicker. And so there's all kinds of different. But there's a very good study which I could send you a link to by some people called Rystad Energy, who have done a cost survey across the UK, across Europe, and the average price across Europe now for levelized cost of deep geothermal heat is €29 a megawatt hour. In France, it's down to €22. Germany's, I think, running at about 30. So the more you do, the cheaper it gets. We're very much still on a learning curve, but once you get good at it, like they are in Paris, bang, 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 it's really cost effective. Does that help?
Thank you. Well, thank you very much.